Hi everybody, it's Dr. Nigro with one more screencast for this unit. This one deals with excess reactants. We just did one that looks at limiting reactants, and now we're going to look at the reactant that remains. All right, so an excess reactant is going to be one of your reactants within any chemical reaction. So we know that in a reaction, the reactant that's completely used is our limiting reactant. All right, it is completely used. The other reactant is leftover and called the excess reactant. All right, so we should have done, or you should have hopefully did the activity with the Jamboards where you were looking at the particulate diagrams of these reactions, and you should have always had one reactant that was still there at the end of the reaction, and that would be your excess reactant. All right, now to work these problems, it's really a limiting reactant problem with some extra steps. All right, so one of the first things you're going to have to do is you have to ID the limiting reactant. All right, if you don't know which one is the limiting reactant, then you can't identify the excess. And we do that using our stoichiometry. All right, once you know which reactant is limiting, all right, then you need to calculate the amount of excess reactant you need to react with the limiting reactant. All right, and again, this is going to be a stoich calculation. All right, finally, once you know how much of the excess reactant you need, you can calculate what's left over. All right, so we calculate the amount of excess that remains by using a little formula. All right, so the grams that remain is going to be equal to the grams you had initially minus the grams that you used in the reaction. All right, and that calculation is what number 2 is right above here. All right, so we got to ID the limiting reactant using stoich. Once we know what is the limiting, then we know what is in excess. We have to calculate the amount of excess reactant needed to react with that limiting reactant. Then we're going to calculate the amount of excess that remains by subtracting what we started with, the initial, minus what we used. Okay? All right, so as I said, these problems tend to come in 2 parts. All right, so I've split this into 2 parts down below. Sometimes they'll be that way, other times they won't. Okay, so we've got aqueous sodium chloride and aqueous lead 2 nitrate reacting to produce sodium nitrate and lead 2 chloride. So as we saw before, our first step is going to be to write the reaction. So we've got NaCl, remember, +1 for sodium, -1 for chlorine. Then we've got Pb2 and nitrate, which is -1. So PbNO3 2. Those react to produce sodium nitrate. So Na is +1, nitrate's -1, so 1 of each. And then we have lead 2 chloride, where Pb is +2, chloride's -1, so we cross those charges and we get PbCl2. All right, for balancing purposes, we've got 2 nitrates on the reactant side, but only 1 over on the product side. So I'm going to put a 2 in for my NaNO3. We have 2 chlorines on the product side, but only 1 on the reactant side. So I'm going to put a 2 in front of NaCl. And then we have 2 sodiums, 1 lead, 1 lead. So we're all good. All right, so for this problem, we start with 15.3 grams of NaCl and 60.8 grams of PbNO3. All right, and the question wants to know how many grams of lead 2 chloride. So here's our unknown. So we're going to be converting from that NaCl over to lead 2 chloride, and then we're going to repeat, but we're going to start with the PbNO3 too. All right, so let's start with our first one. We've got 15.3 grams of NaCl. All right, we're going to convert grams to moles using the molar mass, and 1 mole of NaCl has a molar mass of 58.44 grams. All right, we're then going to convert from NaCl over to PbCl2 using the mole ratio, and according to our balance reaction, 2 moles of NaCl will produce 1 mole of PbCl2. All right, now I'm going to go on to grams because the problem asks for the answer in grams, and once I'm going, I usually keep going. So in this case, the molar mass, but of PbCl2, whoops, I'm missing a PB. All right, PbCl2. All right, and that molar mass is 278.10. It's pretty high. That lead has a lot of mass. All right, so I check my units. Lead moles are going to cancel. Moles of sodium chloride are going to cancel. Grams of sodium chloride. So we're going to be left with PbCl2 in grams, and I got 36.40 grams. All right, so we're halfway there. Now we need to repeat, but we're going to start with the 60.8 grams of the PbNO3 2. All right, just like we saw before, our first step is to go from grams to moles. And using the molar mass, 1 mole of PbNO3 has a molar mass of 331.20. PbNO3 All right, now we're in the mole, but we need to convert over to moles of lead 2 chloride. So we need a mole ratio step, where 1 mole of PbNO3 for every 1 mole of PbCl2. All right, last step, we're going to convert to grams using the molar mass. So 1 mole of PbCl2 has a mass of 278.10 grams. All right, we check our units. Moles of lead 2 chloride are going to cancel. Moles of lead 2 nitrate are going to cancel. Grams of lead 2 nitrate are going to cancel. And we're going to find that we will produce 51.05 grams of the PbCl2 if we start with this amount of lead 2 nitrate. Now, if we compare these two values, this is our limiting reactant, and that is the amount of lead 2 chloride that are going to be produced. So that is just like the limiting reactant problems we looked at before. All right, it's the second part down here, which says how much of the excess reactant is left over. All right, so as I said above, once you know the limiting reactant, which we have identified as sodium chloride, then the lead 2 nitrate must be in excess. So I need to figure out, well, how much of this 60.8 grams is needed to react with this 15.3 grams of NaCl. So to do that, I start with the amount of the limiting reactant, and I'm going to convert that from grams to moles of the limiting reactant. Then I'm going to convert to moles of the excess, and then back to grams. All right, so we start with the grams to moles, and as I saw before, 1 mole of NaCl has a molar mass of 58.44 grams. All right, now instead of going to product, I'm going to use a mole ratio step to go look at the other reactant, and according to my balanced reaction, for every 2 moles of NaCl that react, I need 1 mole of the PbNO3 all right? And I need mass because we're trying to figure out how many grams is left, all right? So I'm going to convert grams to moles, and 1 mole of PbNO3 has a molar mass of 331.20 grams. One good thing about these types of problems is really you've done all the molar mass calculations by the end of the limiting reactant one. So it's not a lot of new stuff. All right, so the moles of lead 2 nitrate cancel, the moles of NaCl cancel, the grams of NaCl cancel, and we find that we need 43.36 grams of this PbNO3 So this is going to be what gets used up during this reaction. All right, now to find what remains, the grams of PbNO3 that remains, I need to know the grams that I had initially and then I'm going to subtract out the grams that I used up. All right, so if I look at the problem, all right, I had 60.8 grams initially, and then I used 43.36 grams during the reaction. So I should have 17.44 grams of that PbNO32 remaining. All right. All right, so it's not that different than the other types of calculations we were doing. It just has a different purpose. All right, so make sure you practice, and if you have questions, let me know.